My name is Julian Chaidez, and this is my path to math. Recently, I've been really interested in the billiard problem. So this is the question of when does a certain shape of billiard table admit a closed orbit, which is a kind of path that the billiard ball can take that repeats itself after some amount of time. This is a very interesting question, basically because it's very difficult to answer, but very simple to state. I came to math in kind of a really roundabout way. So my parents are not science people. My mom is a screenwriter and my dad is a musician. When I was little, I think I really decided that I really liked science. And I think a lot of that was just coming from seeing really amazing scientific figures in like movies and stuff like that. When I was like in middle school, I was actually like demoted in the track. First, I had to argue my way out of the lower track. And then when I got to the higher track, I was really performing badly. Kind of another formative teacher I had, Doug Bueller, he kind of helped me get to the point where I was performing well just by basically making me more organized, kind of helping me make my work neater and express myself better, stuff like that. So I had a high school teacher named Rick Thompson. We had just finished doing some probability stuff, and basically I proved some theorem about the average. And I didn't really realize that that's what I was doing. And then I went to him, and I was really excited by the idea that the thing that I had just proven was new. And I think I didn't really realize that that's what mathematicians did, but he knew that. So he basically, that kind of gave him the idea that I would be interested in that. When I was at MIT, I kind of began to become really immersed in pure math specifically, and started to realize what kind of higher level math was about. You know, the kind of research, the like search for truth, the asking of the questions and kind of answering them by just thinking, you know, and talking to people. And I think that was really, I really like that aspect of it. By the time I was done with MIT, I was pretty set on being a mathematician. I applied to grad school, and I ended up choosing to go to Berkeley. Before I got there, I was not doing research at all, which I think is pretty normal. When I left, I felt like I had a really good idea of what doing research meant. I am really interested in math education. I ran a summer research program for undergrads. The program was awesome. We had a very diverse group. It was half women, half men, which I think is really awesome because generally there's not that kind of balance in most kind of math communities. I mentored the undergrads through some research projects. I tried to explain to them what mathematicians do. The thing that makes the IS so valuable as a resource is its ability to kind of collect together some of the best minds in a particular area. We have had a lot of, young scientists in my area here, and I think the best part of being at the IS has definitely been collaborating with those people and kind of starting new mathematical journeys together. My advice to young mathematicians would be to focus on enjoying what you're doing, focus on enjoying the process of learning, and don't worry too much about how good you are at what you're doing. Thinking too much about failing is the worst mistake you can make. And the thing you should really be trying to do is just enjoy the process of learning the math or doing the math.